You have heard the number 11,000 pounds of bite force, the armored fish that crushed bone like wet cardboard, the one whose jaws supposedly rivaled a T-Rex. For 150 years, that was the story of Dunkleosteus, the deadliest bite the ocean ever grew. Almost none of that number is right. Not because the fish was weak, but because bite force was never one number. It depends on where, exactly, on the jaw you measure. And nearly every telling of this story quotes a single figure, pulled from a study it never names. Two scientists modeled this bite in 2007. What they actually found is stranger and deadlier than the myth. We have been asking the wrong question. Not how hard Dunkleosteus bit, but what strongest bite even means. Because the jaws doing the biting were built like a machine, and the animal swinging them turns out to be half the size we drew. So we rebuild this bite from the one study everyone borrows and no one credits. We take it in order. How the jaw worked. How big the animal really was. That answer changed in 2023, and not the way you would guess. And what the famous number actually measures. By the end, deadliest will mean something far more exact than a figure on a screen. Start with today. The strongest bite ever measured in a living animal belongs to a saltwater crocodile, about 16,400 newtons, recorded in a lab. Hold on to that crocodile. We come back to it. Because the animal we are here for could not match it for raw force, and was still the most dangerous mouth in its world. Wind back about 360 million years, into the late Devonian, a stretch so thick with fish that it is nicknamed the Age of Fishes. The water is crowded with them, most clad in some kind of bony plate. The fossils that started all of this came out of the Black Cleveland Shale of Ohio, first described about 150 years ago. The animal would not even be called Dunkleosteus until 1956, when it was named for a museum curator, David Dunkel. Its world was an arms race, other armored placoderms like the giant Titanichthyes, early sharks like Cladocellaceae, coiled, shelled ammonoids, drifting like floating safes. In a sea where almost everything wore a shell or a plate, the winner is whatever can open it. And Dunkleosteus was the can opener. It answered armor with armor. Thick, bony plates over the skull and shoulders, over the jaws, even a ring of bone around the eye. Nothing else in that water carried a defense it could not eventually crack. Its prey kept evolving thicker shells and heavier plates. Dunkleosteus kept evolving a better way through them. For a while it won every round of that race. An animal that armors its own eyeball is overbuilt for a fight nothing else can give it. It looked like the safest bet in the ocean. It made one of the worst bets in the history of life, which leaves the first real question, the one the thumbnails keep answering wrong. How does a mouth with no teeth end up with the deadliest bite the ocean ever grew? Start with the jaw, because the jaw is the engine. When Anderson and Westneat modeled this skull, they did not draw it like a fish. They drew it like a mechanism, a 4-bar linkage, the kind of jointed system an engineer sketches. 4 stiff parts, hinged so that one motion drives the next. As the lower jaw dropped, the whole armored head tipped back on a joint behind the skull, and the mouth opened from both ends at once. The result was speed. One model has the jaws reaching full gape in about 20 milliseconds, 5 to 7 times faster than you can blink. For a fish the size of a grown person, that is a strange, violent way to feed. Not a slow chomp, but a snap. A shark swings a whole rigid head at its prey. Dunkleosteus did something closer to a machine throwing itself open. Every joint in the skull moving at once, geared so a slow, strong pull came out the other end as pure speed. That part is the one detail almost every video keeps, usually bolted to the claim that it sucked prey in like a vacuum. Be careful there, the fast gape is solid, the suction is not. A 2025 study argues Dunkleosteus was built to ram and lunge, not vacuum. Its mouth too big, with no way to seal it. The honest version is smaller and better than the legend. We know the jaw was fast. What it did with that speed is still being argued. Either way, the open was only half the strike. The close is where the legendary number comes from, and the close is where it falls apart. But before the close, the animal itself changed. For most of a century, Dunkleosteus was drawn as a giant, up to 30 feet, shaped loosely like a shark. That length came from a shortcut. Take the big armored head, assume the body followed shark proportions, and scale the whole thing up. In 2023, a researcher named Russell Engelman checked that shortcut, with a point almost too simple to argue with. Short fish generally have short heads, and long fish have long heads. The old model hung a short head on a long body, and it did not add up. He backed it with a second study. The size of a fish's mouth is a poor guide to the length behind it, which is exactly the assumption the giant estimates had leaned on. Measured properly, Dunkleosteus shrank. Hard. Not 30 feet, about 11 feet for a typical adult, 13 at the very largest. It is one researcher's revision, not a settled vote, but it is carefully argued, and the field has largely taken it up. Here is the turn, though. Shorter did not mean weaker. The new body is short, deep, and dense. Engelman described animals built like wrecking balls. Picture less a long shark and more an armored torpedo. A muscle-bound tuna sheathed in bone. An 11-foot Dunkleosteus weighed about what a 15-foot great white weighs today. The same mass packed into 2/3 the length, right behind that armored head. The monster did not get smaller. It got concentrated. Length had been hiding how strong it really was. And a short, heavy body is an ambush body. Not a long-distance chaser, but a dense slab of muscle and armor built for one short, explosive lunge out of the gloom. So, the bite. Dunkleosteus had no separate teeth. Its jaws were two pairs of bony plates, an upper and a lower blade on each side, with fang-like points at the front and long shearing edges behind. The points gripped and punched through, the edges sheared, and the blades are thought to have sharpened themselves. Every time the jaws closed, bone ground past bone, each edge honing the other. Whether those plates were really teeth is its own argument. When Rooklin and colleagues scanned a close relative in 2012, its plates turned out to be built from true teeth, fused into a single blade. But section Dunkleosteus itself, and you find plain, dense bone, harder along the cutting edge, but with no tooth tissue at all. The same weapon, built two different ways in two close cousins. Which way Dunkleosteus built its own blade is still an open question. But the real secret of this bite is not the blade. It is the difference between force and pressure. Lie back on a bed of nails and you are fine. Your weight is spread across hundreds of points. Step on one nail, and that same weight drives straight through your foot. Force is how hard you push. Pressure is how much of that push lands on a single point. Dunkleosteus was the single nail. Whatever force its jaw made, those narrow, bony edges poured it onto a sliver of an edge. And that is where the famous number finally has to be explained. Now the number. When Anderson and Westneat ran the close on a 6-meter animal, the oversized estimate of the day, they did not get one figure. They got two. About 4,400 newtons at the front fang, about 5,300 at the rear blades. The back of the jaw a bit harder than the front, the opposite of what you would guess. Call it 5,000 newtons, roughly half a ton of force. To put that in a body you know, it takes about 4,000 newtons, a hard blow from the side, to snap a human thigh bone. That is why the numbers you have heard never agree. Different points on the jaw, different models, different guesses at a body we now know was too big. The 11,000-pound version is just a decimal slip of an old press release, off by a factor of 10. Quote the loudest number and you get a monster. Quote all of them honestly and you get an animal. And raw force was never the point. Poured onto that bony edge, the bite reached a pressure of about 147 million pascals, over 20,000 pounds on every square inch. That is the strongest bite estimated for any fish, living or extinct. Not the strongest on Earth. The crocodile we started with still bites 3 times harder in raw force. But the crocodile cannot do this. Snap open in a 50th of a second, then bring a self-sharpening edge down behind a body as heavy as a great white and 2/3 the length. That is what Deadliest was always pointing at, not a record on a chart, a fast strike, a concentrated edge, a wrecking ball body. We were not wrong about it for a century. We were reading it with the tools we had, and the tools got better. Then, about 359 million years ago, the Devonian world collapsed, and every armored fish like it vanished. The best armored animal in the sea, gone, while plainer fish swam on into every ocean that came after. It never lost its edge. It lost its world. Dunkleosteus was the first great predator with a backbone. The first time bone and jaw and armor came together into something that ruled an ocean. But it was nowhere near the first hunter. Go back almost another 150 million years. Before bone, before jaws, before the eye was anything more than a new idea, and something is already hunting in the dark. It is barely the length of your arm. It has no bones at all. It has a circle of plates for a mouth and two spined limbs that sweep prey into it. And for its moment, 500 million years ago, nothing alive was bigger or more dangerous. The deadliest thing in the sea, long before teeth. What does the very first apex predator look like? When something builds a hunter before evolution has invented most of the parts. Tethys codex.